Hello and welcome to our very last lesson of the year. This also happens to be the last shortcut of the year. So let's get things moving. Here is your chance to enter the shortcut club one last time. So here we go. All right. So let's see if you can find the derivative of this function. So why don't you use the derivative definition, the limit definition of a derivative, the limit as h approaches 0, of f of x plus h minus f of x all over h, to find this derivative. Go ahead and pause the video, see what you come up with. Hey, welcome back. Hopefully you attacked this problem with all the energy you have stored up from being inside the last couple days. So you found f of x plus h, you expanded this binomial, you got this nasty looking polynomial, then you plug that into your limit definition, you took the limit as h goes to 0 of f of x plus h minus f of x all over h, you simplified down to that, you used the trick of factoring out in h, and you got 2x plus 33. Well, that's great. And if you can do that, you are set for next year in calculus with your limits. However, some people emailed me last week and said, I think I see the shortcut club. And good for you. That's awesome. There does happen to be a shortcut club with limits of polynomials that happen to look like this. And there are a fair amount of kids who can take a look at this function right here and recognize that this derivative, this f prime of x, is 2x plus 33. And that is the shortcut club. Let's dive in and see if we can enter this club. So here is a function, f of x, and I just made this up. It's what? It's a quadratic. It's x squared minus 79x plus 12,324. And there are some kids who can look at this and say right away, I know what the derivative is. F prime of x is 2x minus 79. Some of you are nodding your heads yes. Some of you are, I'm not sure I can get past the bouncer of this club. Let's take a look at another function. Here's g of x. Now g of x looks frightening. It's 130x squared minus 15.723, only the 23 is repeating, x plus 8. If you're in the shortcut club, you know g prime of x, the derivative of g of x is 260x, 260x minus 15.723 with just the 23 repeating. All right, let's take a look at one more problem before we talk about this club. Look at this. Oh my Lord. Look at this polynomial function. It is humongous and it's also colorful. This is h of x. Let's see if we can find the derivative h prime of x. All right, so let's see. 3x to the 8th becomes 24x to the 7th. This orange one, 2x to the 7th, becomes 14x to the 6th. Maybe I've got a couple more of you. This yellow one, negative 11x to the 6th, becomes negative 66x to the 5th. This green one, 50x to the 4th. This blue one, 4x cubed. This indigo, negative 333x squared. This purple, negative 200x. This black one, 1, 2, 3, 4. And this negative 88 does not exist. Now, you might be a member of the shortcut club. Let's make sure we all belong, though. This thing is called the power rule for derivatives. And it only works for certain functions. It works for functions that are power functions, meaning that you have just an x raised to a power. And the derivative shortcut club for this is this exponent, this 8, comes down and multiplies itself by whatever the coefficient is. 8 times 3, 24. And then whatever this exponent was gets knocked down a power. You subtract 1. 8 minus 1 is 7. Look at this. 7 times 2, 14. You drop the power down 1. 7 minus 1 is 6. The yellow one. 6 times 11, 66. You subtract 1 from this exponent, x to the 5th. And that goes all the way down. Look here. 2 times 100, 200. You subtract 1, x to the 1st. 1, 2, 3, 4, x to the 1st. 1 times 1, 2, 3, 4 is 1, 2, 3, 4. X to the 0. So x to the 0, of course, is 1. That's why it drops off. And of course, there's no x here, so constants disappear. That is called, I got to get this button to work. That is called the derivative shortcut club power rule. Sometimes this is called the exponent rule for derivatives. And it only works for powers. It only works for a variable raised to a power. And you've got to be really careful when you use this, but this is a great little shortcut club. And you know, you are clever algebra students. You can sometimes apply the power rule when others might think you can't. Look how clever you can be. Let's take a look at these two functions. So here you might say, oh, this is not a power. It's just the square root of x. It's not a power function. It's a square root function. Well, that's true in a way, but look how clever we can be. Can't we rewrite f of x instead of using a square root symbol by using exponents? Isn't it x to the 1/2 power? And if we now have a number written as a number to a power, we can take the derivative by taking this 1/2, multiplying it by the coefficient, which is 1. So we get 1/2 x to the, now remember, our trick is we subtract 1. So whatever we have up here, we subtract 1, and that takes us to negative 1/2. Now, we have to clean this up. Remember our rules. We can have no complex fractions. We have to simplify fractions, and we can have no negative exponents. So what's a negative exponent do? It flips a number. So we have a 1 over 2. That's my 1/2. And this x to the 1/2 gets flipped to the denominator. Notice we are allowed to have square roots in the denominator. That's okay now. That rule is gone for us because we have made it to the higher level math. So number 2, can we rewrite roots? This is a cube root. Can we rewrite those using just exponents? Well, sure we can. F of x is x to the 2/3. This is the cube root of x squared. The 2 on top. This number right here goes in the denominator. And so how do we find the derivative? Well, this 2/3 comes down in front. So we get f prime of x is 2/3 x, and then we subtract 1 to the negative 1/3 power. Oop, no negative exponents. So we've got to take this x to the 1/3 and flip it to the denominator. Let's keep going. Let's keep going with this shortcut club. Ooh, well, now remember, this is called the power rule, so we need to deal with powers. And I don't like the fact that x is in the denominator. So can I rewrite f of x using exponents? And the answer is yes, we can. F of x is x to the negative 1st. Remember, negative exponents, they flip numbers. So using my power rule shortcut club, this negative 1 comes down into the front. So f prime of x is negative 1x, and then I subtract 1 from the current exponent, and that's how I get to the negative 2nd. Remember our rules, no negative exponents. That is the derivative of f of x. Moving on, we get f of x equals 5 over 3x squared. Again, we can be clever. We can get this out of the denominator. We can write this as a power function. This is 5/3 x to the negative 2nd. And now that it's written as a power function, we can use the power rule. This negative 2 gets multiplied by whatever's out in front, which gives us negative 10/3. x, and then we subtract 1. Negative 2 minus 1 is negative 3. No negative exponents, so we can rewrite this as negative 10 over 3x cubed. Now, I'd love to show you how this works, but we had to miss one of my favorite lessons of the year because of this social distancing, so we missed out on Pascal's triangle. So next year in calculus class, they will have to be the ones who explain why the power rule works for derivatives, but it is a lovely little shortcut, and you're going to learn a bunch of derivative shortcuts next year. But let's just do one more, and this one I'd like you to try on your own. Here is this giant polynomial. You see we have this first term is written exactly the way we want to write it. These next two terms, not so much. You're going to have to rewrite these. And this one here, you're going to have to rewrite as well. So why don't you give that a go, pause the video, and see if you get the right answer. Hey, welcome back from that pause. Here we go. The right answer is f prime of x is 12x cubed minus 5 over x squared minus, not plus, minus 12 over x cubed plus, not minus, plus 6 over 7x to the 7/4. Now, I do want to put out a warning to you, and that's sometimes kids see the shortcut club and they just start throwing it around all over the place. Beware. This derivative here, you can't use the shortcut club, and what prohibits you from using the shortcut club is this 2 inside the square root. So there is a shortcut club for that next year. It is called the chain rule, and you'll learn how to use it next year, but just be careful on that. Now, your homework tonight, there is a document, a PDF I sent with this. The first 12 are very basic problems. You get to use the shortcut club. You get to crank through all the derivatives rather quickly. Problems 13, 14, and 15 are a little tricky, and you have to think about those. I included the answers at the bottom. See if you can get those answers. And if you can, you are awesome. And if you can't, that's okay. I will put out midweek a little hint about how to do those, but I really want you trying them on your own because, you know, you guys are so smart. And finally, since this is the last lesson of the year, I was really hoping we would be back together in school for 1 or 2 weeks. It's always nice to bring closure to things. But I do want you to know I really enjoyed my classes this year. You guys have so much power to make a class fun, and you really did. You made the class fun for everybody else. You made it fun for me. I really wish we could have a little bit of time together. It came to such an abrupt end for us. Seniors, my daughter's a senior. I know it's tough for you. I really hope I get to see you soon. I don't know anything. This is not a secret hint, but I hope we're creative enough as a district to find a way, seniors, to get everybody back together before you leave for college or your jobs next year. Sophomores and juniors, please come by and visit next year. I'd love to see you. I'd love to see how you're doing. And this was a tough end to the school year, but it's a memorable end at that. So everybody take care. This was our last lesson. Please get the homework into me. And if you have any missing homeworks or any U's instead of S's, you have until a week from Tuesday to get those in. Those have to be into me. It is worth your time to get all S's from me. It is worth your time. You're going to want to do it. So those of you who have all S's, keep it up. Last homework today. Those of you who have any U's or M's, fix it. I am taking homework late. That is rare for me. What a gift. Get those to S's. I beg you. In the meantime, everybody have a great summer.